Okay, so I've decided to take things into my own hands here. And as you can see, I've removed the synthesizer board completely from the tuner. I have it hooked up to a plus 13 and a plus 5 volt power supply, which is all that I need to power the board, or at least power the oscillator section, the reference oscillator. I've replaced some of these little ceramic caps with really good quality NP0 ceramics, and I've connected up. I'm going through the process of aligning it, and I'm doing the first step, which is this trimmer here, which is your 10.2325 megahertz. And if you look at the spectrum analyzer, there's 10.2325 megahertz. If we do peak search, 10.23245, so it's 10.2325 pretty much, and you can see it varies a little bit back and forth, but we're dead on, and it's very stable and it's very good amplitude. Now the problem is I am still not getting my 122.8 megahertz, and I'm really starting to think that our problem has to do with these transistors or the JFETs. So my next thing is I'm going to go through meticulously, and we're going to kind of sort through it till we find the component that is causing this problem. I can peak it a little bit. I get a tiny little, almost zero amplitude, 122.7 megahertz signal. Extremely low amplitude. If it weren't for the spectrum analyzer, it would not be visible at all. You can't see it on an oscilloscope. You can't see it on a frequency counter. It's too small. So we know it's oscillating at the correct frequencies, but there's no amplitude. And my only thing left is it's got to be one of these transistors. So we're going to go through and we're going to figure it out. Well, hello everybody, and welcome back to all the fun. I was out of town for a week and tied up with work and among some other things, so I really haven't had a lot of time to work on the receiver in the last week or so. But I did get a little bit of time on it, and I just wanted to do a really quick update for those of you who are following this series and are interested. After this video, this project is going to get put on hold for a couple of weeks for a couple of very good reasons. But first of all, let's talk about where we are right now. The synthesizer board seems to be working pretty well now. As you can see, we have it put back in, and it's all assembled, and it's working. I was able to go through every single step, and I was able to actually, hold on one second. If you take a look at this truth table right here that we have, it shows you when you're on the different stations what your carrier frequency, your local oscillator, and so forth is going to be, but it also shows you the binary code, and I put the pin of the PLL chip. So this actually is your programmable synthesized PLL, and this chip, even though it has a different part number, which is, I think they call it a TC9100P, it is actually the same PLL chip that is used in CB radios and things like that, and they're just running it at a different oscillator frequency, and they're using a different truth table for the different frequencies of the FM broadcast. So I went through and I dialed up some of these frequencies here, and I actually measured the bits to make sure they were turning on and off as they're supposed to, and in fact they are. Now, in order to do that, since the last video, I did have to make another change to the encoder assembly up here. And namely, what I had to do was I had to remove the LEDs and replace them with incandescent bulbs. And the reason for that was, even if you used diffused white bulbs or diffused warm white bulbs, bright white bulbs, whatever, even with the diffused bulbs, for some reason the LEDs would not spread the light out appropriately in order to cover all of the little sections of the encoder bar, of this little encoder plate back here. So I replaced it with incandescent bulbs. Problem solved. Everything worked perfectly. So I'm sure if we wanted to reprint that little circuit board and redesign it and put the time into it, we could make the LEDs work. It wasn't the light from the LED that was the problem. It was the problem that the lights would not diffuse enough, even with a diffused bulb. I even tried scuffing them up even more with some sandpaper. It didn't matter. So the bottom line is, if you're going to rebuild these, if the bulb is out in one of these, your best bet, if you don't want to make any heavy modifications, replace it with the incandescent bulbs. So I hope my that journey I went through on that, if any of you get any of these to work on, I hope that'll help you guys in the future so you don't go down the same path that I did. But it is working. PLL never locks, and the reason it's not locking is because there are problems in this front end section over here. Now I'm just going to show you real quick. I'm going to make a demonstration and then I'll tell you what I think is wrong. Now, as you remember, we were not able to align these two things here, the coil and the trimmer cap, when we were setting the VCO. And remember, I said that I thought it was this little Vericap diode down here that was bad. As it turns out, that was not the case. I'm glad I didn't replace it. What was wrong was this little trimmer capacitor here, this little ceramic, and luckily I had a brand new one that was the correct value. I put it in there and the VCO aligned perfectly. Went straight out of the book. All the voltages were exactly as the book predicted. Everything went well. I still have a very deaf tuner, and it changes with time. Sometimes it gets more deaf than others, even if you're just standing there. I walked through and I measured the gain of each of these two RF stages. These are dual gate MOSFETs, and I can actually inject a signal here at the very front end, and I can trace it through here and watch it amplify. As soon as it gets to this third one, which it's also a dual gate MOSFET, and we can see that right here. So I inject the signal over here, which would be your antenna input, and I come through RF amplifier 1 and RF amplifier 2. I get all the way to out here. When I get to this little mixer MOSFET, the signal goes in the tank. I mean, it has very low output. It's very distorted, all kinds of strange problems. So let me show you what it's doing here, and I'll show you what I've done to kind of get to where I am right now. Give me a second to set up. Okay, for the first thing, what we're going to do is, you can see I have my probes set right here to test point 13 and 14. And this actually is your IF board, your intermediate frequency board. So this bypasses the synthesizer, the tuner, the tuning gangs, everything. And I'm injecting, as you can see right up here, a 10.7 megahertz signal, pretty strong, and I'm modulating it with a 400 hertz tone. And you can see I get, on the oscilloscope, I get a very clean waveform. Okay, we can look at that. Perfect, no distortion. And if you listen to my little speaker, you can hear I get a sound. Now, that distortion that you're hearing is actually because I'm using this little Radio Shack amplifier, and it has a super high gain. It's a microphone input, and this is a high level, line level output. So the line level actually overdrives the input and can make this sound distorted, but you can hear it. As you can see, basically it is working properly. And there it is. Now, if I move this over to the input over here, I'm going to do that right now. And you can see I have it hooked up. I've not changed anything else on the signal generator or anything. And typically on these tuners, on an FM tuner, if you inject it right at the input where the antenna would be, the 10.7 should pass through all of this, because all the filters and everything are set to allow that frequency to pass. So typically you can actually get your IF to go right through there. And what you notice, if I turn the volume up, I have absolutely no sound at all. Nothing at all. And sometimes, there we go, I had the muting turned on. I turned the muting off. You could hear how deaf it is. It gets real. Let me turn this up without blowing your eardrums out. So you can hear it right there. And you can hear how staticky everything is. So it's like this front end is deaf. It's actually attenuating the signal instead of amplifying it. And it does in fact amplify it out to here. Now watch this when I touch this mixer. See that? And if any of you are regular followers of my channel, you'll see I did that trick on another radio that I was repairing, and it ended up being that transistor was bad. This MOSFET, first of all, if you connect test equipment to it, it swamps things out a lot, so you got to be careful how you hook up your test equipment. But nevertheless, the signal that comes out of here is very, very unstable. It changes in amplitude, and it also gets distortion on the waveform. Really bad distortion. Almost like noise. It looks like noise on the oscilloscope. It's for that reason that I believe this particular dual channel MOSFET is bad. And I think that's what we're going to need to replace. Now, in addition to that, I was able to peak all of these coils and capacitors. And if you look, the little trimmer capacitors that are down here, you can see all of them. You notice some of them are pretty badly tarnished as well. And I have a feeling that a couple of them are a little bit noisy in a similar manner to how this one was. This one was completely shot. It wouldn't work at all. These ones probably could use replacement as well, and in order to do that, I'll have to figure out what value they are, and I will have to order and replace them. And again, we're getting into, I'm not using things that I have sitting on the shelf. I'm going to have to place an order for a couple of parts. They're not expensive parts, but nevertheless, there's shipping involved, there's time involved. I'm really going to need to talk to the owner. I told him that basically because of the learning experience and because of the rarity of this device, that I really wasn't going to charge him for all the work that I'm doing on here and keep things to a minimum. We were maybe going to trade a little bit of equipment or do something like that. But I want to see how far he wants to go with this. My feeling is he'll say if it's a $20 worth of parts or something, go ahead and order it, which I'll do. But that's going to take about a week and a half to get all that stuff in. So in the meantime, we're going to end this series temporarily. We're going to postpone it. I'm going to post this little video, and when I get all that stuff back, we'll put it back on the bench and continue where we left off. In the meantime, I literally have a ton of equipment to go on the bench. I am way backlogged on projects for right now. Part of it has been because this thing has cut into some of my time. Part of it has been I've been out of town, and part of it has been the busy work schedule I've had at work. So we're going to try to get back on track with a few other projects that people have been patiently waiting for me to get to. And until then, hang in there, and we're going to be back real soon with another video that we're going to do here, and then when all this comes back, we'll continue. So thank you all, and I appreciate all your wonderful comments and all the kind words. Those of you who've made donations, you know who you are. I appreciate the donations to the channel. I assure you, as always, that they'll be used only for projects towards the channel and so forth. So thank you all. I wish you all again peace, joy, happiness, and good health in your lives. And until next time, stay well, and bye-bye.